What is a NAND gate? A NAND gate is a combination of an AND gate followed by a NOT gate. The output will be false only if all the inputs are true. These are the conditions of the operation of the NAND gate. We have the symbol which is given, and it is an AND gate and it is connected to the NOT gate. If we look at the symbol with respect to the definition, we have input A, B, the output is AB. And if we had with a NOT gate, we have the NAND gate. Now the symbol will be AB and connected to a NOT gate, which will give us AB, and the bar represent the inverted. If we look at the package view, we can see that there are 1, 2, 3, 4 NAND gate inside the 7400 package chip, and this is nothing but the physical view, and you have pin 1 all the way to pin 7, and on the other side is pin 8 to pin 14. And let us look at the transistor circuit of the NAND gate. We have input A connected to NPN transistor and another circuit of NPN transistor connected to ground, and we have the VCC. The output is now taken from the collector of the first NPN transistor, and it is now connected to the Vout, which is equals to AB bar. And we have input A and input B. To help us understand the NAND gate and the input and the output state, we will look at the truth table. The truth table for the NAND gate is given as we have input A, input B, and we have AB inverted. 0, 0, 0, 1, 1, 0, 1, 1 for combinational input. Therefore, the output we should get from this, and it is stated that the output is false only if all the inputs are true, else it will be false. So we can quickly, by looking at the definition, we can now give the output is false when both the input are true, and for all the other case it is 1. I will now draw the equivalent switch circuit to help us understand the NAND gate. Previously we looked at this portion, which represent the NOT gate with a transistor. Now the equivalent circuit is given such that we have the Vin, which is connected to a lamp, and it is connected to switch 1, which is A, and we have switch B. This is the equivalent circuit, this is the transistor circuit, and the truth table. So we can compute with respect to the first combination in the truth table. When we have both the input is low, that means switch A is open, switch B is open. And what will happen? The current will flow in this direction and the lamp will switch on. Similarly, if we apply 0 volts at the base of these two transistors, this transistor is off. So when both this transistor is off, the current will flow in this direction, allowed to have a voltage drop at the output of this transistor circuit. So the transistor is on or having a state 1. Let us now look at what will happen in combination 2. When we have switch A is open and switch B is closed, now we can see that the current won't pass through switch A. Therefore, even though switch B is closed, there won't be current passing through switch B because switch A is open, and the current will flow in this direction and it will cause this lamp to switch on. Similarly, we apply 0 volts and 5 volts at transistor number 2. Even though this transistor is on, this transistor is off initially, so no current will pass through the first transistor into the second transistor. Therefore, the current will flow towards the output, causing the voltage drop at the output having the state of 1. And what will happen in combination 3? Combination 3, we have switch A is closed and switch B is open. Even though switch A is closed and switch B is open, there won't be a complete circuit in this region because of the switch B is in the open position. Therefore, current will flow towards the lamp and towards the ground, which cause a closed circuit, which allow the lamp to switch on. And we have 5 volts at input A and 0 volts at input B. The current will pass through the first transistor but cannot completely pass to the ground because this second transistor is off and the first one is on. Therefore, the current will choose this path, allow the Vout to have positive 5 volts, which is in the on state, and we can prove from this truth table. And finally, we look at combination number 4. Finally, we have both the switch is closed. When we have both the switch is closed, that means current now will pass through this region to the ground to make a complete circuit, and no current will flow in this direction, making the lamp goes off. Similarly, if we apply positive 5 volts at input A and B, now the current will choose this path and no current will pass through Vout, which is connected to the load. Therefore, the output will be 0 volts, and we can say it is in the off state by knowing in mind that both of these transistors is now in the on state. It is important for you to understand the working principle of a transistor. I have posted the link below. If you want to understand how a transistor operates, you can kindly visit the video and you can be able to understand what really happens in a transistor when we apply the voltage at the base of a transistor to act as a component of switching. I will now give you an example of the application of the NAND gate. Example, burglar alarm. In a burglar alarm, we have the NAND gate itself, which is connected to a buzzer. A buzzer is nothing but a speaker, and it is connected to the ground. And we have a light dependent resistor at one of the input, and the other input we can say it is connected to a switch. What will happen in a case where we want to achieve both the output is equivalent to 0? I want to mention one thing about the current source and the current sink. There is a video for a current sink and current source. You can watch to understand what does that mean. Initially in the system, that means we have positive 5 volts in the two of these input because we want to regulate the switch and the light dependent resistor to have 0 potential when one of these two is switched on to achieve a 0 state. Initially, we have positive 5 volts in two of these input. We know that the output will be low. That's for the fourth condition. We are now in this condition where the output is 0 volts. What will happen if we want to achieve this state? We can say this is input A and input B, and we want the buzzer to go on when one of these conditions is true. For this case, we want the input A to have a logic 1 and input B to have logic 0. By achieving each of these input to a logic state, example 0, we now will have to use the switch B. That means if we apply light to switch B, we have the current from input B to flow towards the ground. When that happens, we now have 0 volts at input B. Therefore, the output will be 5 volts and the buzzer will be on. The important thing to understand in this circuit now wants to achieve a potential of 0. And to achieve this state, we won't do anything with switch A by maintaining the 5 volts at the input A, which is high. We only have to apply light to light-dependent resistor, and this light-dependent resistor will be switched on, allowing the 5 volts to be grounded. When any potential is grounded, it is now representing a 0 volts. The idea can come from if you have a circuit like this, and if you connect without any load and you connect to a ground. This 5 volt source, when it is connected to the ground, it means it is short circuit. So you will have 0 volts measured. Therefore, this logic is maximized in this circuit. And in this case, when we want to achieve a low state at input B, therefore we have to press the switch A, and now we will have all the current from input A to be grounded to achieve the input A as 0 volts, while the input B is 1. That means this is off, and we have retained the 5 volts at input B. Now what will happen? If both the input is 1 and 0, that means the output of the AND gate will be 0. When it is inverted, it will be 1. So we have 5 volts, which means the buzzer is switched on. If you like our video and content, you can kindly like and subscribe to our channel. And let us now look at this state when we have both the input is low. That means we will have to press the switch, and this switch is on, and this light dependent resistor will be on. That means now there will be current flowing to each of these switches, and we will have 0 volts at each of this input. When we have 0, that means the output will be 0 for the AND gate, and when it is inverted, it will be 1. So we have positive 5 volts and the buzzer will be switched on. So this is some of the application in which we can use the NAND gate, and there are many other applications in which you will be able to use a NAND gate to control other devices. So we can see that in a digital system, learning all this logic gate is paramount, meaning it is vital where when you want to build circuits such as a combinational circuit, sequential circuit, it becomes handy. Without the knowledge of how the basic circuit operate, then it will be very complicated for you to understand how a system, especially a digital system, is designed and built. I hope this video can help you understand what is the NAND gate.